Assalamualaikum and good morning everyone. Today I am going to share a subtopic under partial derivative, which is the chain rule. Before we begin solving questions, let us first understand what's the main idea behind this topic. In mathematics, especially in calculus, sometimes a variable does not depend directly on another variable. Instead, it depends on it through another variable. In ordinary differentiations, we usually deal with a function such as y equal to fx and x equal to gt, where f and g are differentiable functions and y is indirectly differentiable functions of t, where we can find y depends on x and x depends on t. So the formula is dy over dt equal to dy over dx times dx over dt. But in partial derivative, a function may contain more than one variable at the same time. For example, z equal to f of x and y, x equal to g of t, and y equal to z. This means when t changes, both x and y also change. Eventually, the z also change. So, in this situation, we cannot use directly ordinary differentiation. Instead, we use a method called chain rule. For functions involving two variables, we can use the tree diagram to construct the formula. We can start from z, break down each root to t, and multiplying its derivative, and then add all the product, which is z is the dependent variables, x and y are intermediate variables, and t is independent variable. So, we can write the formula as partial z over partial t equal to partial z over partial x times with its derivative, which is dx over dt, plus with partial z over partial y times with its derivative dy dt. The symbol here we call as partial, and we use this formula when a function contains more than one variable. So the important step in solving the chain rule questions is identifying how the variables are connected before differentiating. So now we all already know the concept of the chain rule. Then we will go through several examples, starting from simple example involving two or more variables. After that, we will also explain the implicit and the application of the chain rule in our daily life.
Yeah, hi, so today I'm going to explain about an example of chain rule for two variables. The question asks us to find dw over dt if w is equal to x squared y plus 3y, where x is equal to t squared plus y, and also y is equal to sine t. The question also asks us to find the value of dw over dt at t equal to 0. So first, we need to identify the variables that we have. So in this question, we have three variables, which is w, x, and y. So why we need to identify the variables? Because we want to find the chain rule formula. We can find the chain rule formula by using a tree diagram. We know that we have variables w that depends on x. Also, we have variables w that depends on y. We also know variable x is depend on t. Same goes to variable y. We just do like this. It means that x and y is depend on t. After that, we need to differentiate all parts and then add them up. So here we have partial w over partial x. Differentiate x with respect to t, we have dx over dt. Here we have partial w over partial y and also dy over dt. To get the chain rule formula, which is the w over dt, we need to multiply these two things and then add them up with these two things. Okay, so this is the chain rule formula that we get from the question. After that, we need to find the partial derivative. To get the partial derivative with respect to x, we need to treat y as a constant. It means that we need to differentiate only with x. Then treated y as a constant. Then we get partial w over partial dx is equal to 2x, y. Same goes to partial derivative w with respect to y. We need to treat y as a constant. And then we will get x squared plus 3. Next, we need to differentiate intermediate variables that we have, which is x and also y. We just differentiate it like usual. So we will get dx over dt is equal to 2t and dy over dt is equal to cos t. After gather all the information, we just have to substitute all the information into the chain rule. If we have x and y in the chain rule, we need to substitute the value of x and y given to let only variable t in this chain rule. We can simplify it like usual. After that, the question also asks us to find the value of dw over dt at t equal to 0. Then we just have to substitute value t equal to 0 into the chain rule that we got earlier. After we substitute the value, the final answer is 4.
In this part, let us study the example carefully. We are given w equal to x plus 2y plus z squared and x equal to r over s, y equal to r squared plus ln s, and z equal to 2r. So now, we need to find partial w and partial r and partial w over partial s. Look at the tree diagram here. The diagram shows the relationship between all the variables, and the arrow shows how the variables connected and the formula form. To find the partial w over partial r, we can write the formula as partial w over partial x times with dx over dr plus with partial w over partial y times with dy over dr and plus with partial w over partial z times with dz over dr. So, next, we need to differentiate the dependent variables. So, from w equal to x plus 2y plus z squared, we can get the partial w over partial x is equal to 1 because the derivative of x is 1, while 2y and z squared, we are treat them as a constant. The partial derivative with respect to y, we get 2, and the partial derivative with respect to z, we get to z. So after we have done the differentiation for dependent variables, we need to differentiate the intermediate variables. So from x equal to r over s, we get dx over dr equal to 1 over s, y equal to r squared plus ln s, we get dy over dr equal to 2r, and z equal to 2r, we get dz over dr equal to 2. After we have done all the differentiation for dependent variable and independent variable, we can substitute all the value into the formula. 1 times with 1 over s plus 2 times 2r plus 2z times with 2. And then we simplify them into 1 over s plus 4r plus 4z. And we need to substitute z equal to 2r. And then the answer for partial w over partial r is equal to 1 over s plus 12r. Now, let us find the partial w over partial x. This means we follow from w and read down to s. Formula for partial w over partial x, we can write them as partial w over partial x times with dx over ds plus partial w over partial y times with dy over ds and plus partial w over partial dz times with dz over ds. Earlier, we have differentiate for dependent variables. Now, we need to differentiate the intermediate variables with respect to s. So, from x equal to r over s, we get dx over ds equal to negative r over s squared. From y equal to r squared plus ln s, we get dy over ds equal to 1 over s. And from z equal to 2r, we get 0 since there is no s. So, all the value here, we can substitute into the formula and write them as 1 times with negative r over s squared plus 2 times with 1 over s and plus with 2z times with 0. And we can simplify the 2 over s minus r over s squared. Therefore, the final answer for partial w over partial r is 1 over s plus 12r, and the answer for partial w over partial s is 2 over s minus r over s squared.
I will explain the concept of implicit differentiation under the chain rule topic. First, implicit differentiation is used when x and y are mixed together in one equation. Y is not written explicitly as a function of x. For example, y squared minus x squared minus sine of xy, meaning that y is depends on x. We must apply the chain rule when differentiate terms involving y. Next, let's see how the theorem is created from the tree diagram. For differentiating w equal to f of xy with respect to x. Using the chain rule, we get dw over dx equal to f sub x multiple to dx over dx plus f sub y multiple dy over dx. We setting that w over dx equal to 0 and dx over dx into 1. And then we get f sub x multiple to 1 plus f sub y multiple to dy over dx. And we obtain that we get f sub x plus f sub y multiple to dy over dx. And then we rearrange dy over dx equal to minus f sub x divided by f sub y and get a formula for implicit differentiation. Now, let's look at the example. Given y squared minus x squared minus sin of xy equal to 0, find dy over dx. We know that the formula of implicit differentiation is dy over dx equal to minus f sub of x divided by f sub of y. First, we need to define the equations. F of x and y equal to y squared minus x squared minus sin of xy. First, we need to differentiate f sub of x, means differentiate partially with respect to x, which assume that y as a constant and only h change. So, differentiate y squared, we get 0. Differentiate negative x squared, we get negative 2x. And differentiate negative sines of xy, we get, first, differentiate sines, we get cos. And then write it back in bracket, xy, and differentiate xy, we get y. And then we rearrange f sub of x equal to negative 2x minus y cos of xy. Okay, second, we need to find f sub of y, means differentiate partially with respect to y. Assume that x as constants and only y change. F sub of y, differentiate y squared, we get 2y. And then differentiate negative x squared, we get 0. And then differentiate negative sines of xy, we get cos. And then write it back in bracket, xy. And then differentiate xy in the bracket, we get x. And then we rearrange f sub y equal to 2y minus x cos of xy. Okay, now we substitute the value negative f sub of x with negative 2x minus y cos of xy, and then substitute f sub of y with 2y negative x cos of xy. And then we simplify the value and we get 2x plus y cos of xy divided by 2y minus x cos of xy. And we got the answer.
Okay, so now I'm going to explain about how chain rule can be applied in a real life situation involving an electric circuit. The question is given like the voltage B in a circuit that satisfies the law V is equal to IR is slowly dropping as the battery wears out. So at the same time, the resistance is increasing as the resistor heats up. And the equation was given like this. Question asks us to find how the current is changing at the instant when R is equal to 600 ohms, I is equal to 0.04 MP, dR over dt is equal to 0.5, and dV over dt is equal to negative 0.01. So basically, the question asks us to find di over dt. So since the question already given the chain rule for this situation, we just have to find the partial derivative for V with respect to I and also V with respect to R. Differentiate dV over di, we get R because we treated R as a constant. Same goes to when we partial derivative V with respect to R, we will treat I as a constant. Partial V over partial R is equal to I. After gathering all the information, we just have to substitute information before into the chain rule that were given earlier. We will have dV over dt is equal to R times di over dt plus I times dr over dt. So we want to find the di over dt. So how can we find it? We just have to substitute all the values that were given in the question. Just substitute the value of dv over dt is equal to negative 0.01 equal to R is equal to 600 times di over dt, and then plus I is equal to 0.04 and then times with dr over dt, which is 0.5. And then first thing, we can simplify this first. 0.04 times 0.5 is equal to 0.02. After that, we move 0.02 to the left side because we want to let di over dt alone. And if you want to let di over dt alone, we need to divide 600 with negative 0.03. Then the answer, we get negative 0.0005 MP per second. And that is how we can apply chain rule in our life to solve problems.
In conclusion, the chain rule is an important technique in multivariable calculus. Some important formula discussed in this presentation are 2-variable, 3-variable, and implicit differentiations. Overall, the chain rule is widely used in mathematics, physics, engineering, and many real-life applications.